Right. Okay. So a set is a non-sequential data structure. So our sequential data structures were string, list, and tuple.
Tuple.
Though these three were sequential data structures. Under non-sequential, we have set and
Set dictionaries.
Dictionary.
right. These two are non-sequential data structures. Okay. Now what we are discussing about is a set. Set comes under a non-sequential data structure. So when we say non-sequential data structure, which means the elements are not ordered. Elements are not ordered. There is no indexing as such in the set and dictionary, right? So if the elements are not ordered, you cannot um, get the elements through index. So they are not indexed and they're not. Okay. Now another important property of a set is a set doesn't allow duplicates. A set doesn't allow duplicates. Okay, so in list, right, we have seen I can add elements. Right now, 1 is repeated 3 times, 2 is repeated 2 times, and so on. But in set, duplicates are not allowed. It will contain only unique elements. It will contain only unique elements. Okay, a set is mutable. Right, I can add as many elements as we want. We can add as many elements as we want. Right, you can modify it, but it is mutable. It is mutable. Okay, right. Set allows only immutable types as elements in it. Right, what are the immutable types? It can allow string, right? It can allow
Tuple.
tuple, it can allow number, a boolean, a none, right? It allows only immutable types to add as a elements in it. What it doesn't allow? A set doesn't allow list in it. Not allowed. Okay, we'll see as we proceed further. Right, am I clear?
Clear, sir.
Clear,
Yes,
sir.
sir.
Now, what is the syntax for creating a set? Now, set can be created with a simple use this only to create a set, empty set. If you want to create an empty set, you have to use. So far for list, we had two ways, either a square bracket or a list. For tuple, you have two ways, either a parenthesis or a tuple. So for set, if you want to create an empty set, this is the only way. This is the only way. Or if you have elements already, if you know the basic elements already, then you can use a flower bracket 1, 2, and 3. With the flower bracket, you cannot create an empty set. So you should always contain a elements by the time you create a set. Only then it can be, we can use flower brackets. Otherwise, if you want to create a empty set, this is the way to go. Okay, clear?
Clear, sir.
Yes, sir.
Okay,
Yes, sir.
all right. So we will see all the operations one by one. So I can just create an empty set. X is equal to set. Now What is the function that is there to add elements into the set? It is mutable, right? Can I use a function name as append?
We
Can I use a
can't.
function? Mhm.
Yes, sir, we can.
Right. So what does the append name mean? What does the append mean?
We add element in the end.
Add element in the
End.
end. But what is the set property say? It is an unordered collection of elements, which means you cannot guarantee that it will always add at the end. Yes.
Yes, sir.
Hence, you
Sir.
cannot use anything as append. So here for set, we have a function called add. You have a function called
And
add, meaning we are not saying add is add it in the beginning or add it in the, just add it in the set. We don't know where it will be located, but just add it in the set.
okay, sir.
Right. So add 10, it will add x dot add 20 x dot add 10 now. So initially here set will be 10. Okay, when I add 20, it will, the set will be something like this. Now when I add another 10, since it will not entertain any duplicate, so you will not get another 10 added into the set. You will not get another 10 into the set. Set doesn't allow duplicates. Set doesn't allow
Duplicates.
duplicates. Right. How do I check the type of a set? You can use a type function. Now type of X, if I say, it will just say class set. Okay, it will say class set. So we can use, right? We can use set, right? When you don't want to add duplicates and when you don't care about the order and when you don't care about the order. So you can use set when you don't care about the order. Okay. As I said, set will allow only immutable types, right? So x is equal to set. If we just say an empty set x dot add, right? This works. X dot add works. X dot add works. X dot add works. X dot add works. X dot add, I'll add tuple, works. And if I say x dot add, and if I say 1, 2, 3, this will throw an error. This will throw an error. This is not allowed. Here you will get a type error. Type error, and it will just say unhashable. Unhashable. So it will not entertain unhashable meaning, not unhashable meaning it is mutable. Okay. Right. So this is a string allowed. This is a number allowed. This is in the integer and this is going to be a float and this is a boolean. This is none and this is tuple. So all of these are allowed except a list. Right.
Yes, sir.
Yes, sir.
Right. Okay. Now let us look at right. Let me create a new file. But before that, let us try this in the terminal here. So let me just click on the Python console here. Just give it a moment. Okay, I hope you all can see it. Now set x is equal to set. Right. Now x dot add, I'll say 10. Okay, if I see what is there in x, x contains value 10 here. Now again x dot add, I will say 30. X has value 10 and 30. X dot add 5. If you see x, now what is the order? Do you see that order has changed now?
Yes, sir.
First I added 10, later I added 13, later I added 5. Now is it ordered or unordered now?
Unordered.
Unordered, right? It is not following the order like, first I added 10, second I added 30, and for third I added 5. And it is not like 10, 35. Now it is like 10, 5, 30. Right? See now A came first and then 10, then 5, then 30. So it is basically unordered collection of elements, non-sequential, unordered collection of elements. Are we clear?
Clear, sir.
Yes,
Yes,
sir.
sir.
Okay. Now x dot add, I'm going to add 5 again. I'm going to add 5 again. Is 5 already there in that set?
Yes, sir.
Sir.
Now will it create a duplicate entry in that? Let us see. Do we have 5 again?
No, sir.
No, sir.
Meaning x dot add 5, how many ever times, sorry, x dot add 5, how many ever times I try to add that element, and it will never add a duplicate entry into the set. So once it will have only unique values, it will have only unique values. Right? Now x dot add true, x dot add none, x dot add 2.0. Right now x contains so many things. There is a string, there is a boolean, there is a float, there is an integer, there is none, and there is also a tuple. We'll try to add tuple also. Right, so if I look here, now it has got tuple. Now let us try to add list to it. Right, so whenever I try to add a list to it, it says type error, unhashable type list, unhashable type list. So do you understand now? So there are 3 points that we proved. It is a non-sequential data structure. It is unordered. Yeah, it adds only mutable types. It adds only mutable types, right? And it doesn't allow duplicates. And it doesn't allow duplicates. Did we see all 4 points here?
Yes, sir.
Yes, sir. Sir.
Yes, sir.
Okay. Right. So if I want to add an element into the set, is what is the function that I have to use? Add is the function. Now, if I have to remove an element from a set, if I have to remove an element from a set, so I can use remove x dot remove 5. Now let us see what is there in there. Do we have 5 here?
No, sir.
No, sir.
No, sir.
See, I tried to remove 2.0 as well. Now 2.0 is also not present. So if you want to remove an element, you can use remove function. If you want to add an element, you can use add function. Okay. And if the element that I'm trying to remove is not present, remove and I say 100, we don't have 100 here. So here, if we try to remove an element from a set which the set doesn't exist, and in the set that element doesn't exist, then it will throw an error called as key error. Key, that value is not present. 100 value is not present in the set is what it is trying to say. Okay, now we also have one more function to remove the elements, which is called discard, which is called discard. I'm trying to remove 10. So now I was able to successfully remove the 10. X dot discard. I'm going to remove A, right? Perfect, it removed. X dot discard 100. Now again, so when I try to remove 100 using a remove function, it throws an error because there is no 100 in the set. But if I use discard function, it will not throw any error. It will not throw any. If it exists, it will remove. If it doesn't exist, at least it will not throw any error. It will not throw any error. Clear?
Clear, sir. Clear, sir.
Okay. Now, what is the difference between remove and discard in set? Remove removes the element, set also removes the element. Whereas if the value is not present in the set, remove will throw key error, but discard will not throw any error. Discard will not throw any error. Am I clear?
Clear, sir.
Clear, sir.
Yes, sir.
Right? We have one more function basically to remove an element, which is pop, which is pop. Both remove and discard takes a value and removes that. Okay, pop will basically remove any element. Pop can basically remove any element. X dot pop. It is not first, it is not between, it can basically remove any element. It has removed true, and I can say pop, right? It has removed 1, 2, 3, so it can basically remove any element. Okay, now X contains only this much. X contains only this much. So in order to remove an element, you have three functions. One is remove, which takes an object, which takes a value and removes it. If the value is not present, it raises key error. Another function is what you have is a discard. That also, right, helps us to remove based on the value. And if the value is not present in the set, it will not throw any error. It will not throw any error. Okay, and the last one is the pop basically removes and returns that element, removes and returns the element. Okay, clear?
Clear, sir.
Yes, sir.
Yeah, clear.
Right. Now, if you remember in school days, we used to learn something called set theory. You used to learn something called set theory. What is it? What is it? Right. So we used to have something called Venn diagram. You remember?
Yeah.
Yes,
Union.
sir.
Yes,
Right.
sir.
So let us say there are two sets. I mean, this was the syntax that we were using. Now, if I say A union B, A intersection B. Now what happens A union B? A and B, right? So which means I am combining both the things, which is in this case, this is how our set looks like when I union them, which means I'm adding one set with another set. So on this process, it eliminates duplicates. What are the duplicates here? 1 and 3. It will only keep uniques and duplicates will be eliminated. Duplicates will be eliminated. Right. Now A intersection B, what happens there? Now set has what are the common elements? 1 and 3.
3. 3
So
plus
here 1 and 4 are the non-common elements. Here 6 and 7 are the non-common elements. So when I say intersection, give me the common elements. Give me the common elements. So in this case, A intersection will be 1, 3.
3.
Right? And another one is a difference. Right? When I intersect both the sets, right? Both the sets, which in one set I had 1 and 4, which is A. Another set is 6 and 7, B. And common are 3 and okay. So common are 3 and 1. So here 2 and 4 are uniques, right? 2 and 4. Now if I say A difference of B, then it will return a new set. So either it is a union, or it is an intersection, or it is a difference. It will always return a new set. It will always return a new set. So I'm comparing set 1 intersecting with set 2, which is our set 1 is A and our set 2 is B, right? And I'm saying give me the difference element. So in this case, it will return 2 and 4 when I compare A with B. And if I say B with A, then it would return 6 and
6, comma 7.
7. So any operation, either union or intersection or difference, all three operations returns new set. Returns new set. Clear?
Yes,
Clear,
sir.
sir.
Okay.
Yes, sir.
Let us try these. Tried it here only, right? Okay. So here now x dot, let us see what is there in x. I'm going to do one thing. Set 1 is equal to, right? Set 2 is equal to 3, 7, 1, 4. Then 5, I will say. Right. So I have two sets, right? Set 1 dot union set 2. So this will always returns a new set, right? If I check what is my set 1, it is still same 1, 2, 3, 4. What is my set 2? It is still the same 1, 3, 5, 7. If I see what is set 3, what will the values be? It is a union of both 1, 2, 3, 4, 5, 7. Clear? So union
Yes, sir.
means
Clear,
join
sir.
the elements of both the sets, and sets property is to eliminate the duplicates, and that is why we are seeing this behavior where it doesn't contain the duplicates. Now if I say set to 1 intersection set2. What will be the values? Intersection between set 1 and 2?
1, 3.
1 and 3.
1
1
and
and
3.
3.
Right? Are we getting 1 and 3? So this also returns a new set. Right? It is 1 and 3. Now, if I compare set 1 with set 2, what are the different elements? Set 1 dot is equal to set 1 dot difference of set 2. If I compare set 1 with set 2, right? What is the difference I have? 2 and 4 are the unique elements on the set, are the non-common elements when I compare it with the set 2. And in the same way, set 2 difference is equal to set 2 dot difference set 1. Right? 5 and 7. Difference gives non-common elements between the two sets. Non-common elements between two sets. Right? Clear?
Clear, sir. Yes, sir.
Right? Now set 1, I have something like this. Now I want to delete all the elements from set 1. Which function can I use?
Remove function.
Clear.
Clear. Clear. Set 1 dot clear. That's it. If I see what is there in set 1, nothing. It's an empty set. It's an empty set. Okay, understood?
Yes, sir.
Yes, sir. Yes, sir.
Right? Just like union, we also have another function called update. Another function called update. So union, what it does is it joins both the sets. It adds elements from one set to another set and returns a new set. Returns a new set. Right? If I want to modify an existing set itself by adding all the elements of another set. So for example, I have set 1 is this. Okay. Right, set 1, I will just set 1 is equal to 1, 2, 3, 4. Right, I have my set 1 is this and I have my set 2 is this. I want to add all the elements of set 2 into set 1. Set 2 into set 1. Set 1 dot update set 2. I'm adding all the elements of set 2 into set 1. So now let us see what happens with the set 1. Now set 1 has all the elements from set 2 as well. Were we able
Sir.
to add 5 and 7 into set 1?
Yes, sir.
Yeah.
Yes,
So
sir.
you can update the set. You can update the set
Set.
also. Right. So what are the different functions that we have seen so far? Add function is to add elements into the set. Remove function is to remove the elements from the set based on the given value. If the value is not present in the set, then it will throw key error.
Key error.
Okay, we can also use a discard function, which is same as the remove itself, except discard function will not throw any error.
Error.
Right? If I want to remove any random element, right, I can use pop.
Pop.
If I want to join two sets and return a new set, I can use union. If I want to get only common elements between two sets, I can use intersection. If I want to get the non-common elements between the two sets, I can use difference. Yeah. If I want to clear all the data from a set, I will use a function called clear. And if I want to add the elements from one set to another set, update the elements, then I have to use a function called update. Is it clear?
Clear, sir.
Clear, sir.
Okay. Now let us see how to iterate over the set. How to iterate over the set. Now in list, I told there are two ways. Either you can loop through the list directly or you can use the index approach. And same with tuple also. You can loop through tuple directly and also the index approach. Now with respect to the sets, we don't have any index approach. We don't have any index approach. So we can choose to iterate over the set directly. Iterate over the set directly, right? X is equal to, if I have a set like this, right? I can loop the, it is not indexed. We cannot use a regular indexing approach. For ELE in X, I'm iterating through each. So this will get the ELE and it can sometime print 1, 2, 3, and 4. It can sometime do that. Am I clear?
Yes, sir.
Right, you can iterate through the set directly. Now, how do I know how many elements are there in the set? Len function, len of X will return 4. This contains 4 elements. Right? How do I know what is the maximum element in this? I can use max function. Max of X will return 4. Min of X will return 1. Clear?